Welcome to Academia e-learning. So now I'm just going to be doing this past paper here, which was written this year 2023, right? It's one of your March tests, right? It was written by the Johannesburg West region, right? So let's just start off by solving this question 1, right, which we are asked to solve for x, right? So let's start off with this one here, which we have x into 2x minus 3 is equals to 0. So what we know is just going to say x equals to 0, or 2x rather minus 3 is equals to 0. So x is equals to 0, or 2x is equals to 3, and then you divide by 2 both sides here, so x is equals to 3 over 2. So this one, I'm assuming it's simpler for you guys, right? It was one of the simplest problems in the question. So we're done with solving it. Now let's quickly do the second question here. You can see we're having 3x squared minus 5x minus 11, right? I'm just going to write equals to here, right? If you can factorize this, please try, but it doesn't look like it's factorizable, if that's the right word. So we're just going to use our quadratic formula, right, which is x equals to minus b plus or minus the root of b squared minus 4ac, right, divide by 2a. So we're just going to substitute our value of a and b and c. So our value of a in this case is 3, our value of b is equals to minus 5, and our value of c is equals to minus 11, right? And by substituting, we have x is equals to minus our b, as I said, it's minus 5, plus or minus the root of minus 5 squared minus 4, and then our a is 3, our c is minus 11, close, and then we divide by 2, right? Because in this question we're not told whether to leave our answer in SAT form or decimal form, so I guess you have to choose on which form you prefer the most, right? So the SAT forms that you get here is x being equals to 5 plus the root of 157 all over 6, or you'll get another x value, which is 5 minus the root of 157 all over 6, right? So this is the SAT form if you want to leave it in SAT form, because the question didn't specify. But if you want to leave it in decimal, you're going to get 2.922, or x is equals to minus 1.255. So these are the solutions for this problem here. So now we're done. Let's try out the next one, right? So the next question, we also solving for x, this one here. You can see that we have the same factors here of 3x plus 4, right? So having these three factors, so you have x into 3x plus 4, right, and then minus 2 into 3x plus 4. So I want you guys to pay some attention here. This is the same, right? 3x plus 4 is the same 3x plus 4. So why not factorize it? Why not take it out, right? Because it's almost like we're having, let's say, x a minus 2a, right, less than or equals to 0. So what's common here? It's a, right? A is common, so you take it out, remain with x minus 2, right, less than or equals to 0. So that's basically what we're doing. We're going to take out this 3x plus 4. So it's 3x plus 4, and then what remains inside is x, which is this one here, minus the 2, which is this one here, right? So it's less than or equals to 0. So you can just put the brackets like this. So now we're having something that looks like this. Let me erase here. So what we're going to do is we're going to find our critical values. Why are we finding our critical values? Because we're having an inequality sign here, right? So we always have to write our critical values. So critical values are, so it's 3x plus 4 and x minus 2, right? So it's 3x is equals to minus 4, or x is equals to 2. So this is a critical value, and then here divide by 3 both sides, so x is equals to minus 4 over 3. So these are your critical values, not your final answer. Remember, inequality sign. Cool. So from here we are just going to draw our number line, right? then we indicate our critical values. So we have a critical value of 2, so I'm just going to indicate critical value, and a critical value of minus 4 over 3, right? So what you're going to do is this. You're going to test values before your critical value, between your critical value, and after your critical value. So you can choose any value that is before your critical value. For instance, here I chose minus 2, which is less than minus 4 over 3, right? And I chose in between, I chose 1, which is just between 2 and 4, minus 4 over 3, and a number that is greater than 2, obviously I chose 3. So you're just going to test these values here, right? You're going to test it. How do you test them? You substitute them in this equation here. So let's say, for example, you say x is equals to minus 2. So you're going to go to this equation and say, okay, fine, I have 3x plus 4 and x minus 2, sorry, right? And then you're going to substitute this minus 2. So meaning you have 3 into minus 2 plus 4 minus 2, right? And then you punch your calculator and get the answer, right? I'm not really interested in the answer, but punch through your calculator. I'm literally doing that right now. So it's 3 into minus 2 plus 4 and then minus 2, I'm getting 8. So what's mostly important is the sign, right? The 8 that I'm getting is positive, so it's positive 8. What does this mean? It means that any value that is below this critical value here, because I use this one here, any value that is below minus 4 over 3 is actually positive, right? So meaning here we are getting a positive solution, right? And then you're going to do the same thing. You're going to substitute. Now you substitute a different critical value. So I mean, sorry, not a critical value, a different number. So in this case, we're going to substitute this 1, right? You're going to say x equals to 1. Put 1 where there's x and find the solution. So I found that whatever solution that I got, it is negative, so which is mostly important. So you're just going to write negative here, and then you're going to do the same thing, but now you're going to try out x being equals to 3, right? And then what I got is a positive solution, so meaning it's a positive solution there. So once you've identified the signs in your number line, what you're going to do is this. Because you want solutions of x, right? You want solutions of x such that they give you less than or equals to 0 solutions of y. Why am I saying that? Look at this inequality sign. It's less than or equals to 0. So anything that is less than or equals to 0, it is negative. So we are interested in solutions of x that give us negative solutions of y. Where does that happen? It happens here, right? Where our solutions of y are negative. So what do we conclude? We conclude using our critical values. Critical values being this and being this. So we conclude by doing this. So we're going to say x must lie between minus 4 over 3 and less than or equals to 2, right? So it must lie between minus 4 over 3 and 2. Why? Because that's where we get the solutions which are negative, right? Which is what we found here. So yeah, we're done with this problem here. If you didn't understand, please say something in the comments. I will help you out. Let's try out another question quickly. So now we're going to do this one, 1.2, right? It's an interesting question. Basically here you need to know your nature of roots, right? So in this question here we are given a quadratic equation, right? You can see this, and we're asked to determine the value of p for roots that are real. So what are real roots? Real roots, it's a root that is greater than 0. It's a root that, it's a discriminant, sorry, discriminant that is equal to 0. So when you have a discriminant that is greater than 0, you're having real roots. Or when you're having a discriminant that is equal to 0, then your roots are still real. So you don't have to take either of these, but you have to take both, right? So by taking both, you're going to say the discriminant is greater or equal to 0, right? And then what is the discriminant? It's everything that is inside the quadratic equation, which is this part here, 8 minus p cubed. So it's going to be 8 minus p cubed greater or equals to 0. And then you can transpose the 8 to the other side. You have minus p cubed is greater or equals to minus 8. And divide the negative. Always remember, when you divide a negative and there's an inequality sign here, it changes. direction. So where it's facing is going to face the opposite direction. So it's going to be p cubed less than or equals to 8, right? And then obviously, you know, 8 is the same as 2 to the power of 3, right? So it's just going to be p to the power of 3 less than or equals to 2 to the power of 3. And then to remove this power 3 here, we need to multiply by 1 over 3 both sides, by 1 over 3 both sides. So p is less than or equals to 2. So this is the solution of p for this problem here. So now let's go down to question 2. Fine. So now let's do question 2. So what we have here is a quadratic number pattern as indicated here. It's written a quadratic number pattern. So the first question says that we must determine the general term of this quadratic number pattern. So the first thing we're going to do is we're going to write down our sequence, our pattern rather. So it's going to be 11, 20, 33, and 50, right? And then we find the first difference. First difference of this, we're going to get 9, 13, and 17, right? And then so this is called the first difference, right? And then the second difference, we're going to get a constant number of 4. So now to just identify our values, remember that this is the standard form of equation, so we need to identify the value of a, the value of b, and the value of c, right? So the value of a is 2a is equals to the second difference, which is 4, divide by 2 both sides, so our a value is equals to 2, right? And then 3a plus b is equals to the first term of the first difference, which is 9, and then our a is 2, so it's 3 into 2 plus b is equals to 9, and then b is equals to 9 minus 6 because it's 3 times 2, and then b is equals to 3, right? So now we want to find the value of c, right? How do we find it? We say a plus b plus c is equals to the first term of the quadratic number pattern, which is 11. What is our value of a is 2. What is our value of b? It's 3. And then c is equals to 11. Transpose these to the other side. We have c is equals to 11 minus 2 minus 3, and then c is 6, right? So you have your value of a, b, and c. So now you have Tn is equals to an squared plus bn plus c, right? Of which our a is 2, so it's going to be 2n squared. Our b is 3, so it's plus 3n, and our c is plus 6, so it's going to be plus 6 here. So this is your general term of this quadratic pattern. Now we're going to do 2.2, which looks more interesting. I'm hoping you're going to find it interesting. So in 2.2, what are we having? We are told to prove that the sum, it's very important, the sum of the first n difference. So don't know the number of terms. The sum of the first n difference of the quadratic pattern can be given by this formula here. Remember, when I wrote our sequence 11, 20, 33, and 50, the first difference, what was our first difference? Our first difference was 9, 13, and 17. And the statement here talks about the first difference, right? We need to find the sum of the first difference. And the first difference of a quadratic pattern is actually an arithmetic sequence. Always note that. So we are mostly interested in finding that, and we know that the common difference is 4 throughout, so it's easier for us to find the sum of this problem here because our a value is equals to the first term, which is 9, and then our d, which is the common difference, is 4, right? And the sum of an arithmetic sequence is n over 2 into 2a plus into n minus 1 multiplied by d. And then you substitute your n, you don't know how many terms, but you know your 2 into a, which is 9, plus into n minus 1 multiplied by d, which is 4, right? And then you're just going to multiply it through, so it's n over 2 into 18 plus 4n minus 4, right? And then you have n over 2 into 18 minus 4, it's going to give you 14 plus 4n right? And then this n over 2 will multiply everything that it finds inside here. Now we're going to say as n is equals to, so this n over 2 multiplies by this, so we're going to get 14 over 2n plus, and then we have 4n squared over 2. So to write it properly, this is going to be 2n squared plus this one here is 7n. So this is the sum of this arithmetic sequence, exactly the same as this one here. So we're done with question 2. Now let's try out question 3. So question 3, we are told that a convergence geometric series is given by the following. So you can see this is a convergence geometric series, excuse me. And in 3.1 we are asked to find the value of x, right? So what we can do here is this: we can find the common difference. Because the geometric series, it has a common difference, right? Common difference of r, right? So you're going to say r is equal to term number 2 over term number 1 is equal to term number 3 over term number 2, right? And then term number 2 is given by 5 into x plus 1 squared over 9, and it's divided by term number 1, which is 5 into x plus 1 over 3, right, equals to term number 3, which is 5 into x plus 1 to the power of 3 over 27, divide by 5 into x plus 1 to the power of 2 over 9, right? So we are trying to find our common ratio, right? So what you can do is this: you can say r is equals to 5 into x plus 1 to the power of 2 over 9, which is just this part here, right? And it's divided by this bottom part here, right, which is 5 into x plus 1 over 3, right? So I'm just going to change this sign to be multiplication, and these will tip. This will go up and this will go down. So you have 5 into x plus 1 squared over 9 times 3 over 5 into x plus 1. So this will go away with this and will remain with only x plus 1. And then this goes away, remains with 1, and then here will remain with 3. So it's over 3. So this is our common ratio. So you can confirm that by testing this side as well, right, to confirm that this answer is actually correct. Anyways, let me take this one here. So we have our common ratio. We're still not done. We need to identify the value of x, right? And we were told that this is a convergence geometric series, right? So what does that mean? It means the following. Let me write it down. So it means the following: if it's a convergence geometric series, it means that r lies between -1 and 1, right? So what is our r? It's x plus 1 over 3, right? It's less than -1, less than 1. And then now we need to find the value of x, right? So we need to get rid of this 3 at the bottom by multiplying it both sides. So we're going to remove it by multiplying it here, multiply it here, and multiplying it here. So you have -3 less than x plus 1 less than 3, right? And then get rid of this one here, take it that side, you also take it that side. So it's -3 minus 1 less than x minus, less than 3 minus 1, right? So from here, what we can do is, so this is -3 minus 1, which is -4. It's less than x less than 2, right? So this is your solution of x, right? X must lie between -4 and 2. But you need to note that x must never be equals to -1. Why am I saying that? Is if you substitute that -1 into your geometric series, it will give you zeros, right? So it doesn't really form part of the solutions of x. I know that -1 lies between -4 and 2, but -1 cannot be taken as a solution here, because if you substitute here -1, you see -1 is actually the opposite of this one here, right? So it's just going to make everything 0, right? So these are your solutions. You say x lies between this, but it's not equals to -1. So that's the solution. Anyways, let's continue. So now we are told that if x is equals to 1, calculate the sum to infinity of this problem here. So say x is equals to 1, so it means now that you're going to substitute 1 where there's x here. Just going to substitute 1, so it's going to be 5 into 1 plus 1 over 3 plus 5 into 1 plus 1 to the power 2 over 9 plus 5 into 1 plus 1 to the power of 3 over 27. So punch through your calculator so that you can simplify this further. I got 10 over 3, so this is 10, sorry, 10 over 3 plus 20 over 9 plus 40 over 27, right? So and then my r is term number 2 over term number 1 is equal to term number 3 over term number 2, and so this is term number 1, term number 2, term number 3. So you divide out that, you're going to get r being equal to 2 over 3. So this is the final answer for r, and then my a value is this 10 over 3. So a is equal to 10 over 3, r is equal to 2 over 3, right? So remember, we want to find the sum to infinity. So by so doing, we need to write down the formula. So it's sum to infinity is equal to a over 1 minus r. So we already have our r, already have our a. So we can simply substitute 10 over 3 over 1 minus our r, which is 2 over 3. Punch that in your calculator, you're going to get 10 as your sum to infinity, right? So we're done with this question here. So let's go to question 4. So now this is question 4, right? As you can see here, we are given an arithmetic sequence, right? This is your tab number 1, tab number 2, tab number 3, right? And 4.1, you're asked to identify the value of x. So when you are given an arithmetic sequence, you're asked to identify the value of x, you know very well that you're going to use the common difference, which is term number 2 minus term number 1 is equal to term number 3 minus term number 2. So what is term number 2? As I indicated, it's x plus 2 minus term number 1, it's 1 minus x, right, equals to term number 3, which is 2x minus 5, minus term number 2, which is x plus 2, right? So here we're going to get this minus will multiply everything that is inside here, so it's going to be x plus 2 minus 1 plus x equals to 2x minus 5 minus x minus 2, so it's going to be 2x here because it's x and x, and then plus 1 because it's 2 minus 1 equals to here, and here we're just going to get x, and then this 2 we're going to get minus 7. Transpose the 1 to the other side and transpose the x to the other side. You have 2x minus x is equals to minus 7 minus 1, and you have x is equals to minus 8, right? So this is your solution of x. I know it's 3 marks, but yeah, you have to work for it. Now let's do 4.2. 4.2, we are told that if the first 3 terms of this pattern are, so if we're having these 3 terms, right, calculate the numerical value of the sum of the first 100 terms, right? So if we are having a sequence of 9 minus 6 minus 21, right, obviously it's an arithmetic sequence. So what would the sum be? What is the sum of this sequence? We are having n being equals to 100, so those are the terms. A is equals to 9, right? And the difference is equals to minus 15. Please try that out. Minus 15. This is term number 1, term number 2, term number 3. So find the difference between term number 2 minus term number 1 and see if you won't get 15. It's definitely 15. So you're just going to write down the sum, which is n over 2 into 2a plus into n minus 1 multiplied by d, right? So it's sum of 100 terms, right? So it's 100 over 2 into 9 plus into 100 minus 1 multiplied by minus 15, right? And punch this in your calculator, you're going to get minus 73 1350. So this is your sum of 100 terms, right? So now let's go to 4.3. We are done with this one here. I'm guessing this was quite easy, right? So if you wrote this exam, now you see your mistakes. If you killed it, congratulations. Yeah, and if you have any papers that you wrote in March that you'd like me to do, let me know in the comments, and yeah, we can share emails so that you can send it through. Now let's go to 4.3. Hence or otherwise calculate the value of m, right? So this is going to be a long step, by the way. It's 4 marks. I'm assuming they're stingy. They should have given at least something like 6 marks, because I believe it'll take a bit of, a bit of fun. Let me say that. So what we can do, let's first find the first 3 terms for this before we even go further. So you can see that n starts at 0, right? And we're having a sum of 100, which is the answer that we got in the previous question, and then we're having this. So let's first find the first 3 terms of this sum on the left hand side. Excuse me. So when n is equal to 0, it's 24 minus 15 into 0. So basically it's 24. That's the first term. When n is equals to 1, it's 24 minus 15 into 1, right? So it's going to be 9. And then when n is equals to 3, so it's 24 minus 15 into 3, right? So you should get minus 6. So the first 3 terms is 24 plus 9 plus minus 6. So these are the first 3 terms of your sum, right? So this is what you're going to do. We're going to find the sum of this, right? But before we find the sum, let's find the number of terms. You know the number of terms. If you're given a sum like this, you say n is equal to top minus bottom plus 1. So what is the top? It's m minus 1, right? I'm going to put brackets. Minus what is bottom? It's 0 plus 1. So my n is equals to m minus 1. Okay, this is 0 plus 1, right? So n is equals to m, basically, right? So we're just going to write down our sum now. So we know n is equals to m, right? So we're going to write down the formula for our sum, which is the sum of an arithmetic sequence is n over 2 into 2a plus into n minus 1 multiplied by d, right? And our n is equals to m, our a is equals to 9. No, I'm lying. What did we find? We found 24. Thank you. If you saw that, it was 24, the one that we calculated here, because it was 0 here. And then our d, what was our difference? Our d is minus 15, right? You can check that out. D is minus 15. So then we substitute. So S of m is equals to, remember, by the way, we are looking for m. That's the question. We're looking for m. So S of m is equals to m over 2 into 2 into our value of a, which is 24, plus into m minus 1 multiplied by minus 15, right? And then the sum, let's just simplify here before anything. So it's going to be m over 2 into 24 times 2, which is 48, and then minus 15m plus 15, right? And then here, when I have m over 2 into, so it is 48 plus 15, which is 63, minus 15m, right? So it's going to be, this m over 2 will multiply everything that is inside here. So you will have 63 over 2m, right? Minus 15m squared over 2. So this is the sum of m terms. Remember, we want to identify the value of m. So this is what you're going to do. You're going to raise the top, right? So now that we found the sum, and by looking at this question here, we are told that this sum that we found, S of m, is equals to sum of 100 plus 73320, right? So S of m is equals to S of 100 plus 73320. So what is S of m? It's what we found here. So it's 63 over 2m minus 15m squared over 2 is equals to S of 100 is what we found in the previous question, right? Which is minus 73350, right, plus 73320, right? So it's going to be 63 over 2m minus 15 over 2m squared is equal to, so please find the difference between these two here. I'm getting minus 30, right? And then from here, just to simplify everything, I'm just going to remove this 1 over 2. So we're just going to have 1 over 2 into 63m minus 15m squared is equals to minus 30, right? And then I multiply by the 2 both sides, so I'm going to have 63m minus 15m squared is equals to minus 60, right? So from here, this is what you're gonna get. So remember there's brackets here. So from here you can just bring the minus 60 to the other side, so you can just write down 63m minus 15m squared plus 60 is equals to 0, and then you just write it in standard form, so it's minus 15m squared plus 63m plus 60, right, is equals to 0. So you can just simplify further so that you'll be able to factorize. We can divide by 3 all sides, right, by negative 3 actually, negative 3 all sides, and then I'm gonna get 5m squared minus 21m minus 20. Please confirm that. So that's what I'm getting, and then now you factorize and you identify your value of m. That's why I said this question deserves at least 6 marks and not 4 marks, right? But anyways, so we have 5m squared minus 21m minus 20 equals to 0. So to factorize this, 0 here, so we're going to have 5m plus 4 and then m minus 5. So 5m plus 4 is equals to 0, or m minus 5 equals to 0. So 5m is equals to minus 4, or m is equals to 5, and then divide by 5 both sides here. So m is equals to minus 4 over 5, or m is equals to 5. So obviously we were not going to take the m is equals to minus 4 over 5, so we just leave it. This is the solution for this problem here. So we're done with question 4. So now let's go to question 5. Okay guys, so now let's quickly do question 5, right? So what we have here is a hyperbola, as you can see in the diagram here, and 5.1 we are asked to find the value of p and q, right? So how do you find the value of p? First, you identify your vertical asymptote. This is your vertical asymptote, which is x being equals to minus 3, right? So to find the value of p, you're going to use this here. It says x plus p, so we know it's equals to 0, right? And we just found that x is minus 3, so we're going to say minus 3 plus p is equals to 0, so p is equals to 3. So this is the value of p, which is equals to 3. And then for q, we find this horizontal asymptote here, so q is equals to minus 1. So these are the solutions for 5.1. So now going to 5.2, it says that we're having a straight line, so let me take it up. So we're having a straight line of g of x is equals to minus x plus k, which is one of the axes of symmetry of f. Determine the value of k. So this straight line is one of the axes of symmetries which actually move here, move like this, right? Because it's a negative axis of symmetry, right? So this g of x, we are given as minus x plus k. So we are asked to find this k here. So the only way we're going to do this is by using our asymptotes, right? So our vertical asymptote is equals to minus 3. Our horizontal asymptote is equals to minus 1, right? And g of x is equals to minus x plus k. So where there's y you put minus 1, where there's x you put minus 3, right? So it's plus k, and then here it's going to be minus 1 is equals to 3 plus k. Transpose the 3 to the other side, you have k being equals to minus 1 minus 3, which is minus 4. So this is your value of k, which is minus 4. So we are done for this question here. And then we go to the 5.3, right? So 5.3, what we have is we are told that h of x is equals to minus 2 multiplied by g of x, right? Determine the equation of the inverse of h, which is this one here, in the form of a straight line. So that's why they said the inverse is equals to mx plus c. So we are asked to find the equation of the inverse, right? So the first thing we're going to do is we're going to identify h of x. So h of x is equals to minus 2 g of x. But what is g of x? G of x is what we found in the previous question, which is g of x is equals to minus x, and k value was minus 4, right? So h of x is equals to minus 2 into minus x minus 4, which is 2x plus 8, right? So this is h of x, right? And then to find the inverse, we know that h of x, instead of writing h of x, we're going to write y is equals to 2x plus 8, and then we swap. Where there's x, we put y. Where there's y, we put x, right? So this is going to be x equals to 2y plus 8, and then we write in standard form. So it's going to be 2y is equals to, so this 8 goes to the other side, so it's x minus 8, and divide by 2 both sides. So our y is equals to x over 2 minus 8 over 2, right? And then the final answer would be y is equals to x over 2 minus 4. So this is the inverse of the problem here in 5.3. So we're done. Going to go to 5.4, right? So 5.4, we are asked to sketch neatly the graph of h and the graph of the inverse of h, and what we need to show are the intercepts, points of intersection, and the axis of symmetry, right? So what we do is this: we're going to draw our graph here, right? And then remember our equations, right? Equation of h of x is equals to 2x plus 8. So basically this 8 is our intercept, it's here, so it's 8, right? And if you substitute 0 here, so 0 is equals to 2x plus 8. Transpose the 8 to the other side, you have 2x equals to minus 8, divide by 2 both sides, x equals to minus 4, right? So that's your x intercept, so it's going to be somewhere here, minus 4, and then you join these two, oops, and then you, let me just redraw this. So you're gonna, sorry about that, so you're gonna join these, gonna be something like this, and then we're asked to draw the symmetry, right? Which is the axis of symmetry here, we are told. But before we do that, let's draw the other equation, which is the inverse. So the inverse is equals to x over 2 minus 4, right? So our y-intercept is minus 4, it's somewhere here, right? So it's minus 4, right? And then obviously if this is 8, then our x would be 8, right? Remember, it's an inverse of h. So when you draw, it's gonna look something like this, right? And yeah, so now that we drew this, we need to indicate our symmetry, right? So our symmetry is going to go through in between these inverses and past the origin and go straight up, right? So it's going to be our y is equals to x, right? But you're not done. Remember that we were asked to indicate the points of intersection. This is the point of intersection. So we need to indicate the coordinates of that point of intersection. How? We're going to say, okay, fine, we have h of x. H of x equals to the inverse of x, right? So what is h of x? it's 2x plus 8 is equals to x over 2 minus 4, right? So you're going to do your cross multiplication. Obviously not now. I wanted to remove this 2, but let me just transpose it to the other side. So it's 2x minus x over 2 is equals to minus 4, and then I transpose 8 to the other side, it's minus 8. And then I'm going to have 3 over 2x is equals to minus 12, right? Multiply by 2, both sides. If 3x is equals to minus 24. Divide by 3 both sides. So x is equals to minus 8, right? And then we want to identify the value of y. So we know h of x equals to 2x plus 8. And we found x to be minus 8. So it's going to be h of x equals to minus 8 is equals to 2 into minus 8 plus 8. So it's going to be minus 16 plus 8, which is equals to minus 8. So our x and y is minus 8. So meaning here our coordinate is minus 8 and minus 8, right? So those are coordinates of the intersection. So yeah, that's how we do this one. We are done solving for question 5. Now let's go down to question 6, which is the last question for this paper. So what happens is we are given f of x being equals to ax squared and g of x being equals to b to the power of x, right? We are told that they are sketched on the same set of axes, and we're given a point of a, which is minus 1 and 2, b. We are not told that point, but it's an intersection between two graphs, and the turning point is 0, which is at the origin here, right? Fine. So now 6.1, we want to identify the value of a and b. Remember, for f of x, we are given ax to the power of 2, and we can use this point here of a, right, being minus 1 and 2 to substitute. So where there's y, you put 2 equals to a into minus 1 squared. So a is equals to 2, right? And then for g of x, which is b to the power of x, our y is 2 equals to b, which is unknown, minus 1. And then it's 1 over b is equals to 2. Cross multiply, we have 2b equals to 1. b is equals to 1 over 2, right? So we have found our values of a and b. A being equals to 2, b being equals to 1 over 2, right? Fine. So now 6.2, the inverse of f is not a function. That's what we are told. Write down at least one condition on which can be used to restrict the domain of f such that its inverse will be a function. So remember, this is a parabola, right? This is a parabola, right? Its inverse will look something like this, right? This would be its inverse. So to make this a function, the inverse a function, to make it a function, because it's not a function, it doesn't pass the vertical line test. So to make it a function, we need to restrict the domain. How do we restrict the domain? Remember, because it starts at the origin of 0, you're just going to say when x is less than or equals to 0 or x is greater or equals to 0. So those are going to be your restricted domains, right? And we are done with this question here. So let me erase this. So now going to 6.3, let me erase this first. 6.3, for which values of x, where x is the element of minus infinity to 0, so it's from 0 here to minus infinity, right? Will this happen? So when g of x is less than or equals to f of x. So this is g of x, right? This is the graph of g of x. When they say it's less than, which means it's at the bottom of f of x. When does that happen? Here. If we check here, it's bottom. The g of x is bottom. And the f of x is top, right? So when the value of x, when that happens, simply you're gonna use this one. Let's just use this one. Yes, there's many ways to solve this, but let's use this point here. Here x is equals to minus 1. So when x is less than or equals to minus 1, g of x is less than f of x. So you can simply just write this as your solution for this problem here, and then you'd be done. Now let's go down to another question, which is 6.4. 6.4, we are given h of x, which is g of x plus 3. So what this means is, what was our h of x? I'm sorry, what is our g of x? G of x was equals to, let me just go confirm. G of x is actually the exponential, right? Which we found b to be half. So it's going to be 1 over 2 to the power of x. But here we are told that there's a shift. 1 over 2 into x plus 3, right? So there's a shift. This means that it's a shift. So it's x plus 3 equals to 0, x equals to minus 3. So it's a shift to the left hand side, right? So what does that mean? It means any value that is found in this graph of g of x is going to shift 3 units to the left. For example, this a value here, it's going to shift 3 units to the left, meaning this 2 will remain the same because this is a horizontal shift, right? So meaning it's going to be somewhere here. Maybe our value of a is going to be here, which now is going to be, so if you say 3 units to the left, it's going to affect this negative 1. So you're just going to add, we're going to say minus 1 minus 3 and 2. This is going to be the new value of a, which is minus 4 and 2, right? So which is what this question here actually looks for. It says we must find this value of a, which is the new coordinates for the graph of h. So we just answered the question, right? So yeah, this is the value of a, which is minus 4 and 2. Why? Because there's a horizontal shift of x is equals to minus 3. And then going to 6.4.2, we are asked to find this value of a, which is the new coordinate for the inverse, right? Inverse of h. So if this is h, which its value is this one, which is what we got to be minus 4 and 2, then the a value for the inverse would be 2 and minus 4, right? You just swap this. This would be your y value, this would be your x value. So this is going to be your answer for the last question. So we're done with this question paper. I hope you enjoyed. If you haven't subscribed, please do subscribe. Thank you so much. If you didn't understand anything, let me know in the comment section below. Otherwise, thank you so much for watching.